This is cascaded variable gain amplifier. In this, we are providing the input voltage. Input voltage is around 0.375 volt and 150 megahertz frequency and pulse generation. And this is positive rail voltage, 10 volt. And this is the control signal we are providing. That is a reference voltage. Reference voltage is around 10 volt initially. After 1 microsecond, it is 100 volt. So how much voltage it is able to provide this amplify, how much voltage it should amplify, that is provided by the reference voltage. Here there is input voltage and load voltage. Load voltage initially it is around 10 volt. Okay, it is slight oscillation is there. This is DC voltage. Load voltage is DC voltage. And here, after it is increased, the load voltage reference is increased to 100 volt. Here the voltage is increased. Input voltage is constant. For constant input voltage, we are providing variable output voltage. So it is variable gain amplifier as it is boosting the voltage. And there is V in by V naught ratio, gain ratio. Initially it is around 22, then it is increased up to 250 times. Okay, initially we are providing 10 volt as reference and the measured voltage it is following the reference voltage. After 1 microsecond, we have increased the reference voltage to 100. So this variable gain amplifier, it is slowly increasing. The load voltage is slowly increasing and reaching up to 90 volt. It is reaching up to 90 volt. This is to check whether the variable gain amplifier can amplify more like that. I am providing higher value to test the limits. 100 volt as the reference I have provided, but it is slightly reduced. 90 volt we are getting. And these are the common mode error CMRR voltage, common mode rejection ratio. That is del V naught by del V in. So change in input voltage, change in output voltage by change in input voltage. It is nearly zero here. Initially it is increased higher. Then it is going to 5 volt, then nearly zero is coming. For output voltage of 100 volt, the input voltage is, the CMRR value is nearly zero. And maximum value we are getting around 5 volt, 5 to 6 volt. So the common mode voltage will be in the ratio of within 5%. We are getting 5% as the common mode voltage. And here it is we have plotted the board plot for variable gain amplifier. For low gain operation, here this is the response magnitude and the phase angle. And for high gain response, this part is high gain response part. Here, this is the response, it is 80 dB. And then it is reducing here. As the frequency increases, it is reducing here. So here we are getting maximum gain at the time period of 100 megahertz frequency, 100 megahertz. And here we have provided the input as 150 megahertz. So we are getting higher gain here. If we reduce that, means that gain will be reduced here. AC voltage we have provided as input, and here it will be converted to DC. It is between this and this. It will be converted to DC, this and this. And we are providing cascaded transistors so that we can improve the gain value.